Alright guys, and welcome back. So in this video, we're going to start talking about some more tests that we can use to determine whether a series converges or diverges. Let me give an example of why this test is going to be useful. So we know that the series of 1 over n squared converges, right? And we use the ratio test, it's a p-series, whatever. But the question you might have is, what if we just looked at a very similar series? So say the sum from 1 to infinity of, I don't know, like 1 over 2n squared minus 1. Like, you might look at this and say, hey, this series is actually pretty similar to the series of 1 over n squared. It seems like this would also converge. And the answer is yes. But the reason for why it does, and the way we can prove why it does, is the limit comparison test. So here's what the limit comparison test says. If you have two series, so if you have a sub n and the series b sub n, if these are both series with positive terms, what that means then is, if they're both series with positive terms, if you take the limit as n goes to infinity of the ratio of those terms, so a sub n over b sub n, it doesn't matter which one's on top, by the way. If you take this limit, and this limit is equal to any number, which is not 0, and obviously if it's a number, it's not infinity, then what that means is either both of those series will converge or both of them will diverge. So either both series converge or both series diverge. Basically, they're going to have the same behavior. Okay, so that's kind of what this is. Let's unpack this. So this limit comparison test says you have two series with positive terms. You take the limit of the fraction between them, and as long as you get a number, they both do the same thing. So you have one test that you know about, like 1 over n squared, and the other you don't know about, and you'll prove it this way. Okay, so let's talk about why this works. Basically, you're saying, say you get a number like 2. What that's saying is that one series is just 2 times the other. Meaning if one series converges, say it adds up to, I don't know, 6. Then if you have, the series of b sub n, if it's twice as big, then it's going to go to 12. Or if one series is, or if the limit's 1/3, if one series is 6, the other series is 2. If one of them is infinity, if you multiply infinity by a number, you're still getting infinity. So they're both going to diverge in that case. So that's the logic behind why this happens. Let's look at some example problems of where you're going to use this. So for example, let's suppose we have to show that the series, 1 to infinity, this one we just looked at, of 1 over 2n squared minus 1 converges by comparing it with the series of 1 over n squared. Okay. So kind of looking at this notation, this is going to be like your a sub n, this is your b sub n. So what we're going to do is we're going to take the limit. So we're going to go ahead and take the limit n goes to infinity of one of these over the other. So 1 over 2n squared minus 1 divided by 1 over n squared. Now, you're in calculus, so you know that you can flip the fraction on bottom, and this is just equal to n squared over 2n squared minus 1. Now, when you take this limit, well, you can either use L'Hopital on this or leading terms. Some of you guys just know this is 1/2 or whatever. But let's go ahead and do L'Hopital. This is the same as the limit n goes to infinity of 2n over 4n, which of course is 1/2. Okay, now, again, the number you get doesn't matter. It just has to be any number that's not 0 and not infinity. So because we got a number, since we know that the series of 1 over n squared converges, and we know that because, of course, it's a p-series, that means that by the limit comparison test, by the limit comparison test, so does the series of 1 over 2n squared minus 1. Okay, and that's all this is saying. As long as one of them converges, this one obviously also converges in that case. Okay, so that's what's going on there. Let's look at another example like this. So this is one where you are going to need to use L'Hopital's rule. So I'm going to ask you the question, does the series of sine of 1 over n, let's say from 2 to infinity, although the starting point doesn't matter, converge, or does this series diverge? And what we're going to do is we're going to compare it to the series of just 1 over n by itself. So again, when we kind of think about our notation, this is my a sub n right here, this is my b sub n right here. So this just becomes the limit n goes to infinity of sine of 1 over n divided by 1 over n. Okay, now we're using the limit comparison test, so we're looking at this. Let's go ahead and take the limit of the top and the bottom separately. So when we take the limit n goes to infinity of sine of 1 over n, that goes to sine of 1 over infinity, which is the sine of 0, which of course is just 0. If you do the limit on bottom, you take the limit as n goes to infinity of 1 over n, which is 1 over infinity, which of course is 0. Okay, so we'll go ahead and use L'Hopital's on this. So this is going to equal, the limit as n goes to infinity. The derivative on top is cosine of 1 over n. And then by the chain rule, we multiply by the derivative of 1 over n, which then is negative 1, so that's negative 1 over n squared. All right, now same derivative on bottom, negative 1 over n squared. I mean, you can simplify this a little, but I think all the cool kids recognize that these cancel. So you're just left with a cosine 1 over n. So this just becomes the limit n goes to infinity. Well, we wrote that already. It's cosine of 1 over infinity, which is the cosine of 0, which is 1. Again, the number you get doesn't matter. And like, if you get 0 or if you get infinity, like, this test doesn't help. So if we took this limit and we got 0, this test would be inconclusive and we'd have to do something else, like maybe the integral test or something. But anyway, because we got this number, that means that they have the same behavior. Now, we know that the series of 1 over n diverges. The harmonic series is a famous series, P series, whatever. So that tells us that the series of sine of 1 over n also diverges. Okay. So that's the limit comparison test, and that's how it works. One of the questions I often get asked is, how do you know what to compare to when you're using this test? And generally, they're going to tell you when to use this test. But either they'll give you something to compare it to, like they'll give you something like this, or it's going to be like a really easy P-series, and we're going to talk about that in the next video. Okay, so that's the limit comparison test, guys. I hope this helped. Thanks for watching. I'll see you all soon.